There are many ways to preprocess images. Here I just mentioned some of them which are often used with CNNs. First, we can normalize the data per channel, for example by computing the mean values of pixels for each channel, RGB, through the whole data set and subtract this value to each corresponding channel. In this way, no relative information inside each channel is lost. Note that many other normalization techniques exist. A set of techniques often used in deep learning are data augmentation. Data augmentation consists in creating new images based on the existing ones on the dataset to increase the size of the dataset on which the learning algorithm is trained. Imagine, for example, that a cat is in an image. Then you can create many different images based on this one by sampling or cropping. You take small pieces of the original image and you give the attribute cat to all of them. If a cat is present on the big picture, it is likely to be present, at least partially, on all sub-pictures. You then add these sub-images to the dataset. There are two benefits in data augmentation. First, you increase the size of the dataset and thus the learning ability of the resulting predictor. Secondly, you make the predictor robust to the variations you have considered. If you take one image and its horizontal flipping, the resulting algorithm trained on these images will be probably invariant under horizontal flipping. This is usually a good thing when you want to detect objects in images. You can also consider translations, rotations, or photometric transformations to perform data augmentation. At test time, when you want to predict, you are going to create as many transformations of the image as you did in the training set, translation, rotation, subsampling, and so on, obtain a prediction for each transformed image, and predict the class of the original picture via a majority vote. Augmentation can be seen as a way to regularize a predictor by making it invariant to some transformations. Other ways to regularize are adding noise to inputs, weights, outputs, or also selecting the best transformations in a data-driven way. Note that the last idea is computationally expensive. Some references can be found in this slide if you want to learn more on this topic.